Hello Algebra 2ers, this is Mr. Hotard. This is going to be a short video on graphing systems of quadratic inequalities. We've graphed quadratic inequalities in the past. This is just going to be graphing systems. Since it's more than one, usually it's a good idea to have either two different color pens, or if you have maybe a pencil and a pen, just to help keep track of which one's which. All right, but I'm just graphing each of these inequalities and I have to shade it, and I'm looking for where the shaded areas meet. So this first one, all right, y greater than or equal to 2x squared. There's no numbers behind it, so I know this one's going to start at 0, 0. From that point, I can go up 2 over 1. It won't keep going up 2 over 1. It's not a v, it's a u. And then remember, if there's an equal to line, is that solid or dashed line? It's going to be a solid line. So that first parabola is going to look like this. Going to be a parabola, solid line, keeps going up, and then it's greater than, so would I shade above or below these points? The solutions would be above it. So all my solutions to that first one, and I don't want to make this too dark because that's not the final answer. That's the solution to the first one. All right, now the second one, I'm going to do this one in a different color. This one, the plus 1, going to move my graph which way? Up 1. So I know that first point, the vertex can be right here at 0, 1. And then from there, got a negative in front, like a negative 1. So it's going down 1 over 1. And then this one does not have an equal to line, so this is going to be a dashed line. It does not actually include the points on this parabola. And then I've got a less than. So would my solutions be above or below that red parabola? It would be below it. So everything below this on the inside of this parabola. So now I'm just looking for where the two shadings meet. All right, where all the solutions are. And that's in just this very tiny little area. I'm going to darken that. That small area, all those little, it's all decimal numbers in there. Those would be solutions to both of those inequalities. Now let's look at one more. Let's skip over to number 3. All right, now this one, going to be a little bit more difficult to graph because you can't get the vertex straight from the problem. All right, this is written in standard form. If you recall, there's a formula to find the vertex. X equals what? Negative b over 2a. So for this first one, I would get x equals negative 4 over 2 times negative 1. So negative 4 divided by negative 2, which is positive 2. Now once I know x, remind me again, how do you find y? You plug it in. Plug that in for x. Y equals negative, parentheses, 2 squared plus 4 times 2 minus 4. And I'm going to work that out. So that's going to be 2 squared is 4, then put a negative on it. That's negative 4. 4 times 2 is plus 8 minus 4. So negative 4 plus 8, that's 4 minus 4. I'm getting 0. So that vertex is going to be at the point 2, 0. So let's plot that. That's going to be right here. And then look in front of the x squared, there's a negative 1, so from that point I can go down 1 over 1. And then this time, equal to line, solid line or dashed line? It's going to be a solid line. It actually includes the points on this parabola. And then less than, shade below. So all my solutions to that first inequality are here on the below those points, so inside of that parabola. And then now I'm going to just get a different color and I'm going to work this second problem out. I need to get my vertex, so x equals negative b over 2a, so negative 2 divided by 2 times 1, which is going to be negative 2 divided by 2, which is negative 1. If I plug in negative 1 everywhere I see x, y equals negative 1 squared plus 2 times negative 1 minus 8. So that would be positive 1 minus 2 would give me negative 1 minus 8. I would get negative 9. So this vertex is going to happen at negative 1 comma negative 9. So let's plot that. Left 1, down 9. Right here. And then look in front of x squared. There's an automatic 1 right there, so I know that graph would go up 1 over 1. Again, it doesn't keep going up 1 over 1, it curves, but I can make my parabola now. No equal to line, so it's a dotted line. Does not include the points on this parabola. And then less than, would I shade above or below? less than I would shade below these points. Now if I go below, is that inside or outside? That's outside the parabola. So all these points, and again, I don't want to make it too dark because everything outside of this red parabola would be solutions to this. And again, I'm looking for where the two shadings meet. I'm looking for where both of these are solutions. And I'm just going to darken that. So everything, not in this little section, but from the outside of the red parabola and inside of the darker one, all of this, all of these points, they would all be solutions. Okay, so now I want you to go ahead and try the other problems on the page. I hope you tried them. Let me just show you the answers again. Just check, it's going to be just the darker areas where your solutions are. Okay, now just a heads up, some of these are going to be decimals, like number 5, actually the whole bottom section. Number 4, you wind up getting x is 1.75, y is 10.125, so it's going to be just slightly off. It's all right, you still plot those points. All right, and then same thing happens in number 5. You get some decimal numbers, like you get x equals -1/4 or -0.25. Plug that in for x, you get y is -5.125. And so your vertex isn't going to be right on the line, it's going to be a little bit off, but it should look similar to those. And again, the dark area, that's where the two shadings meets, that's the solutions we're looking for. Okay, I hope you're figuring this out. Hope this was helpful. This is Mr. Hotard signing out.